All right, we are starting a new chapter now, chapter 4 on integration. And this is the third really big idea of this course, Calculus AB. The first being limits and the introduction to limits. And that led us into the second big idea of derivatives and differentiation. And now this is integration or the antiderivatives, which essentially we're going to be going backwards from the derivative process. Okay, so let's get that down. The antiderivative is the reverse of the derivative of an equation. That's what we'll be finding. And in this video, we'll be taking you through some of the basics of how it works, the notation, and then going through a couple of more basic problems. Okay, some notation involved here. All right, so we're finding all solutions of this equation of the antiderivative. That's called antidifferentiation or indefinite integration. It's denoted by that symbol you see there, and the general solution can be denoted by the following. Okay, so let's just take a look at some parts of that. Okay, so this is essentially the process we're going to be going through. All right, so this is the process of finding the antiderivative or integrating this function f of x. Okay, so that's that symbol right there that says that we're going to be doing some integration. That's the function we'll be dealing with. This right here is going to be telling us which variable we're finding the antiderivative in terms of. So in this case, it would be x. And then this right here is the result. Okay, so as I'm finding the antiderivative of this function, this is the result. And we have the capital F of x. And then we have this c here, which is the constant of integration. And we'll go through some examples of and we'll see why that's necessary to throw in that c at the end there. Okay, let's take a look at the process here, how this is going to work, and a quick review of finding the derivative. Okay, so we're looking here at a function which is f of x equals 7x to the third power. So we wanted to find the derivative of that. Okay, so we're still doing that here. So that's going to be f prime of x, the notation. And the way that this worked out, I'm going to go real slow here. We're going to, using the power rule here, we're going to take this exponent and multiply it by this coefficient, and that's going to give us 21. Then what we'll do is we'll subtract 1 from the exponent, and that's going to be x squared. Okay, so going from this to this is finding the derivative. Let's review. And now we're going to be focusing on, well, what if we started here and we had to get here? Can we figure out how to do that? And if we think about the steps that we used, we just have to go backwards. So let's just think about this. How did we get here? Well, first of all, we multiplied the exponent times the coefficient. Okay, so we took the 3 times the 7, and we got 21. Okay, but we didn't stop there. Then we had to subtract 1 from the exponent. Okay, so that's the process of finding the derivative. So hopefully this is intuitive. We're now going to take the antiderivative, or do antidifferentiation. Essentially, that means we're going to have to go backwards. Okay, so if we were starting with our 21x squared, so let's just say we have f prime of x equals 21x squared, and we wanted to find the original function here. Okay, what would that process be like? So what we're going to do is we're essentially going to take these steps here and reverse them. Okay, and not only do the inverse operations, but we're also going to reverse the order, okay? So first we multiplied, so that means that we're going to have to do division to undo that. And then we subtracted, so we're going to have to do some addition to undo the subtraction. But the order, we're going to do this part first. We're going to undo the subtraction part first. So let's just think about this. What we'll do, instead of subtracting 1 from the exponent, we will add 1 to the exponent. Okay, and then after we're done adding 1 to the exponent, instead of multiplying the exponent times the coefficient, we are going to divide. coefficient by the new exponent. Okay, so let's just see how this is going to play out over here. Okay, well, first of all, we have to take this x squared, so we're going to add 1 to it. So, we'll change this up here. So now we're going to say, okay, well, instead of it being x squared, well, why don't we'll write it out first. We'll say this is 7x squared. So what we'll do is we are going to now add 1 to that exponent. And actually, sorry about that. We are going to start off with a 21x squared. Okay, so now we will add 1 to that exponent. So that's going to be 3. And then we're going to divide the coefficient by the new exponent. So we will divide by, we can just call this 2 plus 1 down at the bottom. Okay, so what now happens is, that is 21x to the 2 plus 1, that's going to be x to the third. And now we'll take that 3, we're going to divide the coefficient by that 3. So the 21 gets divided by 3, so that becomes 7. Okay, which is now we're back to where we were before. All right, so that makes sense. Now the one thing we do have to add on, though, is this plus c. And that's going to be our final answer. You think, well, why do we have to add the c there? Well, that c is a constant of some kind. So it could be an 8, it could be a 12, it could be a negative 1, or it could be 0. And the point is, if we were to take the derivative of this, this 7x cubed would turn into 21x squared. And then whatever the c is, the derivative of that is going to be 0. So if it's 8, it's going to be 0. If it's 0, it's going to stay 0. So now we don't know what this constant is. We just know when we find derivative, it turns into 0. So that's one thing we just have to remember for each one of these is when we do the integration, or the antiderivative, we do have to add that plus c at the end. Okay, so let's just take a quick look at the notation here, just to be clear about what we just did. What we just did in that last process was the following. We took, we integrated now 21x squared dx. Okay, so again, this is the symbol for integration. This is the function we had, and that is the variable that we were doing it in terms of. Okay, so we did that, and the result was 7x cubed plus c. Okay, so that is the, and then we can just kind of circle that right there. So that is our end result in terms of the integration process. So hopefully this process isn't, it makes sense and it's intuitive. We're going to try a few more problems just to make sure we have it. And these are the more basic ones. We'll eventually have to do more challenging ones. So here's some practice. We'll go up here. Okay, so first up, let's just do the following. So it's going to be 3. We're going to find the antiderivative of 3x dx. And let's just think about the process here. We said, all right, we're going to add 1 to this exponent here and then divide by that new exponent. So that's going to end up being 3x to the second power, because we're going from 1 to a 2, and then we have to divide by 2. And then we will add the c. Okay? If you want to just change the way that looks a little bit, you can. We can say that's 3 over 2 x squared plus c. That's fine. Okay? So that's how that one works. Let's try another one. Okay, so this is going to be, we're going to find the antiderivative of 8x cubed in terms of x. Okay? And on any of these, feel free to pause the video, try it on your own first, see if you get it right. But again, the process is add 1 to the exponent and then divide the coefficient by that. So that's going to be x to the 4th power. So we're going to say that's 8x to the 4th power. Then we'll divide that by 4. We'll throw in the constant of integration. And then we'll see if we can reduce that at all. So 8 divided by 4, yep, we can call that 2x to the 4th power plus c. Okay. And on any of these, if you wanted to make sure you are correct, you could find the derivative of this, of your answer, and see if you get the original problem there, which in this case we would have. Okay, we'll try two more. So in this case now, what if we see something like this? Okay, well, one way that on some of these examples it may help to rewrite. So for instance, we can think about this as 10x to the 0 power, right? If it's just a constant like that. All right, so therefore, now if I add 1 to this exponent, that's just going to be 1. So this is going to be 10x to the first power, all divided by 1, but we can just leave that as 10x, and then plus c. Okay, and again, if I find the derivative of 10x plus c, it's just going to be 10. So we know we did that right. And then finally, last one here, let's say we have the following. We have the square root of x dx. Well, again, I'm going to rewrite this. So that's going to be x to the 1/2 power dx. So I think about that now. I'm going to add 1 to the 1/2. So that's going to be x to the 3/2. And then I need to divide by 3/2. And then I will say plus c. Okay, so this is a big mess right now. We do need to clean this up. There's a couple of ways to do this. To me, I think the simplest way to go about this is, all right, we have this x to the 3/2 being divided by 2/3. Well, when we divide by a fraction, what we can just do is multiply by its reciprocal. Okay, so I'm going to change this now. If I multiply by 2/3, it's going to look like that. 2/3 x to the 3/2 power plus c. And if you want to put that into root form, you could do that. You can have the square root of x cubed. That's fine if you want to change it like that, but otherwise we'll leave it there. Okay, so hopefully this video has helped with the process of anti-differentiation. We'll get into more complicated things later on, but this was just a way to give you a general sense of what we're going to be looking at in the next couple days and weeks. And if you have any questions, you can ask me in class, and I'll be sure to help you out then. All right, thanks.